Bob Herbert's OpEd.tv is made possible in part by the CUNY TV Foundation with the support of Ann Ulnick. Hi, I'm Bob Herbert. Welcome to OpEd.tv. Climate change, with its rising temperatures and rising sea levels, its wildfires and extreme weather events, is a profound threat to much of the life on this planet, including human life. And yet we are not taking anything close to the steps necessary to mitigate this existential challenge. Here in the United States, climate change is for the most part ignored. Ambitious proposals to expand mass transportation and radically reduce the use of carbon-based energy are routinely dismissed and often are ridiculed. What's going on? I'll explore some of the hard truths about climate change and what we all should be doing with my guest, one of the wisest minds on this issue. He's Alex Halliday, director of the Earth Institute at Columbia University and a former dean of science and engineering at the University of Oxford. I might add that he has recently been honored with a knighthood in Britain for his services to science and innovation. How are you, Mr. Halliday? Thank you so much for coming in. I really appreciate it. So it seems clear that the consequences of climate change, many of which are upon us even as we speak, will be worse than a lot of people realize. Is there a way to sort of summarize kind of the threat that we're really facing?
That's a very good way of putting it, because the threat hasn't been properly understood, and it's partly because it's been quite hard to model it in a forward way. But maybe I could just lay it out for you with a bit of a history of how climate has changed.
That'd be great.
And why we're worried about what might happen in the future. So I'm a geologist originally. I study the Earth. The Earth started 4.5 billion years ago. So if you just go back 1% in the history of the Earth, that's 50 million years, there was no ice caps. There were no ice caps in the Antarctica. There were no ice sheets. There were no ice sheets in Greenland or in the North Pole. The temperatures were many degrees higher than they are today. And since 50 million years ago, gradually the Earth, for reasons that are complicated geological reasons, some of which we don't understand, the Earth's surface has been getting cooler over time, over the last 50 million years. And about 40 million years ago, we saw the first evidence of the development of ice sheets in Antarctica. And then about 3 million years ago, you saw the development of glaciation in the North Pole and the development of ice sheets in Greenland, etc. And so gradually, although it's basically there have been times when things haven't changed very much, and then it's got colder quite fast, etc. And then it warms again a bit. Overall, over 50 million years, things have been getting cooler on the surface of the Earth. And if you look at go through the ice sheets, people drill down the ice sheets through the ice sheets in Antarctica to go to, there's a lake under the ice sheets in Antarctica called Lake Vostok. And the Russians drilled all the way down to sort of get samples of this lake. And the ice core that they retrieved gives you samples of ice trapped over hundreds and hundreds of thousands of years. And so we can see what's been happening just in this last bit of Earth history. And what you can see is that the Earth, we can get bits of the ice, get air that's trapped in the ice, and we can measure the carbon dioxide concentrations. There are ways in which we can calculate the temperature as well at those times. And we can see that over the last several 100,000 years, the Earth has been oscillating in and out of ice ages. And we all learned this in geography, so you all know about the ice ages that affected Central Park, for example. You can see the glacial striations when there are ice sheets here. You went from warmer to colder every 100,000 years, and you can see that the CO2 changed from about 100 ppm when things were colder to roughly 300 ppm when you're an interglacial.
So there's evidence of the changes in the carbon dioxide.
Yeah, but it's basically driven by a natural process, and actually the Earth is basically It's the way the Earth precesses around the sun on its axis as it's going around the sun, and that actually changes the amount of heat coming to the Earth, and that drives this ice age phenomenon. We don't understand everything about that either, but you can see that roughly the natural way of the Earth behaving is that right now we would have about 300 ppm of carbon dioxide in the atmosphere. That's the natural state for us to be in a warm interglacial
300
period.
parts per million.
Parts per million, yeah. If you look into these ice core records in more detail, just the last few thousand years, you can actually see that you've got these numbers around 300 parts per million of carbon dioxide. Until the end of the 18th century, around 1769, James Watt invents the much more efficient form of steam engine, and you expand the Industrial Revolution fantastically.
So prior to that, it's relatively stable, the amount of carbon dioxide in it. Okay.
Yep. And then suddenly you see it start to take off, and it's rising faster than ever before, as far as we can tell, in the history of the Earth. So it's now gone from around 300 ppm to in excess of 400 ppm. We're getting more and more carbon dioxide in the atmosphere, and scientists 100 years ago predicted what this would do, and that there would be that because carbon dioxide is a greenhouse gas, you end up with increasing the temperature of the surface of the Earth. And basically we've seen this happen. There's a lag to how long it takes for these things to take place, about 10, 30 years sometimes, 10, 20, 30 years, because of the way in which the carbon dioxide cycles through the Earth and the temperature effects. But the net result is the last 50 years we've seen a pretty steady rise in temperature at the surface of the Earth, and we've increased the temperature by about 1 degree centigrade, which is 1.5 degrees Fahrenheit, since 100 years ago.
So what's happened is we've had this intense industrialization on the planet, especially in the large advanced countries. And that's coincided with this rise in the amount of carbon dioxide. And so explain how, you've said it's a greenhouse gas, but explain how this causes the planet to warm and what the effects are that we're already seeing and what we can anticipate.
So carbon dioxide is one of a few greenhouse gases that there are in the atmosphere. It's actually not the most potent one. Methane is extremely potent, and the chlorofluorocarbons are also very potent, but they're in much lower concentrations. But methane is also an issue in terms of what may happen in the future and what's been happening with leakages and the issue of agriculture, etc. as well. But the net result is that of a greenhouse gas is that it basically it absorbs heat from the atmosphere, and so the atmosphere ends up locking in more of the heat that's coming in from the sun, and as a result the temperature ends up basically being, instead of heat being reflected back out to space, we actually lock the stuff inside the atmosphere. We trap it. Mm-hmm. Other things can affect, of course, this behavior. For example, the ice sheets themselves reflect heat and light back out to space. Clouds reflect heat back out to space. And so, to some extent, if you remove the amount of ice cover, then you also worsen these effects.
So you don't get that reflection from the ice.
You don't get that reflection, so there's what we call a positive feedback. That is, you're driving increases in temperature with carbon dioxide. That in turn melts the ice sheets. That in turn reduces the amount of reflection back out into space, and that in turn increases the temperature of the surface of the Earth even further. So people are worried about what this may lead to in terms of a runaway effect, where you actually go through some kind of a tipping point where one effect actually generates another effect, which generates another effect. The other thing people are very worried about is the effects on the clathrates, which are this technical term. There's methane trapped in the tundra in the northern hemisphere, which is where there's ice at the moment and cold conditions. If you start to warm too much, there may be methane release from there, and again that will accelerate global warming.
That would have a similar effect to the carbon dioxide, just make it warmer and warmer. Now there's no question that much of this rise is caused by humans, by industrialization, by industrial processes, is there? Because this is the climate deniers want to say, well, this is just a natural event, and we can't be sure that humans have much to do with this.
Yep.
How do you respond to that?
Well, you can see the natural event. We can see the history of how CO2 has changed naturally, and we can see the temperature changes naturally as well. What we're seeing most recently is completely different from that. It's off scale, and it's actually CO2 driving temperature. The natural thing is for temperature to actually allow CO2 to come out of the interior of the Earth
Right.
and into the atmosphere. So we change the temperature that way. This is nothing like that. This is unnatural. This is CO2 driving temperature by pushing CO2, if you like, poking the Earth, poking the climate
Right.
system with extra CO2 in a way that we've never done before. And so in terms of what that means for the future, trying to model it is very complicated, but the models are getting far more consistent now. Just even measuring the surface temperature of the Earth so that you've got a global average. It's taken a while for people to get that really accurate, but we've got good ways of doing that now, and all the models are in pretty much clear agreement, and they've been that way for the last couple of decades. So the effect, though, is that, of course, what's going to happen, the most obvious effect is you're putting more heat into the surface of the ocean. That's leading to more water vapor going into the atmosphere, and that's leading to bigger storms and things like that.
I probably started paying attention to climate change and global warming probably in the latter part of the 20th century, I guess in the early 90s or something like that. But what's struck me is that all the predictions of the scientists are coming true right before our eyes. I mean, they predicted, I don't know how long ago, but I know they predicted 30 years ago or so, that we were going to get these more intense storms, that there would be intense flooding, that there would be wildfires, that there would be droughts. I mean, all the things that we're seeing now. We're seeing, storms, flooding that's supposed to be once in a century, happening once every 10 years or even more frequently.
Mm.
If that is happening already, and they are, I mean, the devastation in California and other parts of the United States from wildfires has been staggering. If this is happening right now, and the temperatures are continuing to rise, and we're not mitigating that, what can we expect?
So, good question. I mean, to be fair, I think what's happened in the past is that people have said, well, droughts, storms, these things happen.
These things
anyway.
happen, right.
So how do you know this is climate
They always
change?
talk about, the Dust Bowl of the 1930s.
Right. And it's when the 100-year events get repeated every 5 years, or maybe even every year, you start to realize this is not normal. And similarly with the wildfires repeating themselves on a regular basis. You're getting to the point with wildfires that the natural process of regeneration of forest areas and things like that, there's not enough time for that to happen, and so actually species are going to be wiped out in those areas. But to give you some idea of what will happen, at the moment we're looking at a sea level rise, for example, of about 3 millimeters per million years. Now 3 millimeters per year.
That would be all right.
That's right. That would be fine.
And we'll take that.
But 3 millimeters per year doesn't sound too bad either. It's not.
Right.
That's not. It's like, what's the big deal
But
about
it
that?
is.
But the thing is that if you look back 100 years ago, it was about 0.5 millimeter per year. So it's actually accelerating, and so the sea level rise is accelerating. How bad it might get isn't particularly clear, but there are two important aspects of this. One is that even a small amount of sea level rise, like with global warming, we think we've identified about 1 foot of sea level rise around this area. The effect that it has on storms and storm surges is very significant, because it means that actually the storms get further inland, and because of the way that the shallow way in which the shoreline operates and is defined, it means the storms get further inland, and they can be more devastating as a result. And then on top of that, you've got the effects that some of these storms, because they're more intense, that they can be more intense, but also because of the changing climate system, which we didn't really understand, storms just seem to stop and just carry on raining, as we saw in Hurricane Harvey, and we saw just down the coast last year. This is something that people are actually experiencing for the first time. They're saying, okay, things are different now with climate change, the weather's behaving differently. But to get the second point to this is that if you know, even 1 foot over a year doesn't sound too bad. The thing people are worried about is that if you look at the ice sheets, people have tried modeling what will happen to them in the future. And what they've found in the last couple of decades is not what they modeled. And so the models said one thing, and then they started to see evidence of ice sheets actually carving off, big chunks, big cracks appearing and becoming unstable in certain places. And this could lead to much, much larger rises in sea level.
They just plunge into the ocean.
Yeah, they basically break off. There are a variety of things happening, but one of the things that is happening is actually the it's the flow of the ice off the ice sheet, off the North Pole and the South Pole, that is driving this. But there's also warm water, or relatively warm water, coming in from the oceans and undermining the ice sheet underneath. And people are worried about how that may operate. And if you look back at what happened when we came out of the last ice age, 13,000 years ago, it's clear that there were very, very large increases in sea level associated with major deglaciation like this. And we may be talking about not something of the order of, in 100 years, seeing sea level go up by a foot or something like that, or what we may be talking about is something in the order of several meters of sea level. So we could actually see, which is more like 10 feet in other words. So that is something that people are really increasingly worried about, that we're going to see fairly major change. This happened 13,000 years ago over several centuries. So it happened over and over again. So actually we saw huge increases in sea level taking place at the end of the last ice age. And the question is, given that we haven't really observed this before, how do we know just from models whether we might not repeat some of this behavior with the ice sheets as we start to force poke the climate system as we're doing at the moment? So people should be really worried. If you think about the total amount of ice that's on the ice sheets today, in terms of the North Pole and the South Pole, there's 10 times more in the Antarctic than there is in Greenland and North Pole. The total amount, if you were to melt it, it would increase sea level by 64 meters. And that's where we were, 50 million years ago. It's going to be different going forward.
They begin to wipe out coastlines. I mean, in cities like New York, or coastlines like Florida here in the U.S., other places around the world, it would be devastating.
Yeah, and if you look at, say, someone's done an estimate of which, in terms of GDP, which are the most vulnerable populations, where are the major centers in terms of economic loss. And there are 5 of them in the eastern US. And of course, that's New Orleans, there's Miami, there's St. Petersburg, there's the area around Boston, and then, of course, the area around New York and New Jersey. So these are major areas, but there are plenty abroad as well. And we need to worry about Mumbai, we need to think about some of the places in China, and we need to think about other low-lying communities that where lives are going to be lost in huge numbers. And this doesn't form, people don't factor in loss of life as part of the economic model. It's not that it's not part of GDP. So people need to seriously think about this and think about what we don't know about the climate system that could be far worse than we've actually thought about so far.
So we thought we were making progress on international cooperation with the Paris Accords, the Paris Agreement, which I think was 3 years ago. But those were, they established voluntary goals, but we're not even meeting the voluntary goals, are we? What happens if we just continue sort of muddling along as we've been doing?
Well, I think, again, that's part of the problem with trying to predict it exactly. It's a complicated system. The way the atmosphere is going to behave is something we're figuring out as we go along to some extent.
But won't we start to get things like disruptions in habitable areas, and can't we anticipate climate refugees and problems with disease and these sorts of things?
So the major things that people are concerned about are the effects of drought. There is evidence that the Syrian civil war was to some extent driven by issues of food security, which led to people moving into the cities, which led to strife, etc. Similarly, there's evidence that there were food security issues that were climatically driven, which had something to do with the Arab Spring and that uprising. The net result is that people will actually migrate, and they will look to find new places to work and get food and somewhere to survive. And the impact that has is both in terms of conflict, but also in terms of immigration, has been very clearly seen in the Middle East, and the effect it's had on Europe in particular, just in the last few years. And so I think we need to, if you think this is someone else's problem, you should think about what this has done to the way the politics has played out in Europe with Brexit and everything else.
Right.
Over the last few years, because it's quite clear the ramifications for everybody are going to be huge of these kinds of conflicts.
Because governments haven't responded in the way that I might have hoped and many others might have hoped, and especially here in the United States, I'm pessimistic. Is my pessimism misplaced? Is there reason for optimism, or are you just as pessimistic as I am?
I think it's part of my job to be an optimist.
All right.
I think so, and I think there's actually lots of grounds for optimism in the sense that I think increasingly people are changing their thoughts about climate change and the fact that we have to get serious about it. And so, there are vested interests, quite clearly, of course, in not decarbonising the economy. This country has done so brilliantly on the back of hydrocarbons, on the back of the automotive industry, on the back of the space and aeronautics industry. These are massive parts of big success stories for America. So if someone comes along and says, well, we actually got to change all that.
If we could get focused. Right.
So I think there's trying to get people to think, well, actually, what are the opportunities that exist in coming up with new technologies that take carbon out of the atmosphere, or new technologies for transportation, or new ways of doing energy storage. And a lot of clever entrepreneurs and investors around the world are thinking really hard about that because they want to be in on it. And there are opportunities for many, many people around the world to be part of that. There's also opportunities because, I'm just back from China, and it was pretty clear that a lot of the people in China, they're aware of climate change, but they're mainly aware of it from the point of view that they've got terrible pollution as a result of all the coal-fired power stations, etc. And so they really want to do something about this.
The problem is right there in front of their very eyes. They're breathing it every day.
So there are great benefits for public health as well if we actually move towards a cleaner way of doing energy and transportation.
Well, we have to stop there. Professor Alex Halliday from the Earth Institute at Columbia University, thank you so much for spending time with us.
Thank you very much. Very enjoyable.
We'll be back in a moment with a final word. There is no end to the malevolence, the sheer mean-spirited destructiveness of Donald Trump and the Republican Party. Having declared war on immigrants and trampled the voting rights of millions and given aid and comfort to white nationalism and other forms of bigotry, they have now renewed their unconscionable effort to wipe out the Affordable Care Act, Obamacare. Trump's Justice Department has joined a lawsuit pushed by Republican leaders in several red states that would destroy the Affordable Care Act. If Trump and the GOP get their way with this lawsuit, the health coverage for more than 20 million people would disappear. Insurance companies would no longer be required to cover applicants with pre-existing conditions. Parents would no longer be able to keep their children on the family's policies until the age of 26. The Affordable Care Act is now embedded in the country's healthcare system, and it has become widely popular. If it is dismantled, the suffering that would result would be immense, and make no mistake, people would die. For what? What possible rationale could there be for such wantonly destructive behavior? What's the source of this hideous compulsion to do harm that has such a hold on Donald Trump and his party? In the movie 42 about Jackie Robinson, Branch Rickey, played by Harrison Ford, is asked why he was so insistent about integrating professional baseball. He said that he had realized some years earlier that there was something unfair at the heart of the game he loved, and he had ignored it. He wasn't going to allow that to happen again. I feel that way now. There is something truly terrible at the heart of the country that I love. We can't allow ourselves to become in any way complicit with that. We can't just avert our eyes and allow it to continue. It would be an affront to all that we claim to believe as decent human beings if we allow ourselves to ignore it. That's all for now. See you next time.